Good afternoon, second years. Today's lesson, we are going to be consolidating what we learnt yesterday when we started to look at some of the theorems from geometry. So we looked at Theorem 1 regarding vertically opposite angles. And we remembered that that was an X shape created from two straight lines, rays, or line segments, or a mixture of each, creating these four angles then in between the sections of the X. And we decided that the opposite ones were equal in measurement. We looked at Theorem 3, which is regarding alternate angles. So this time, if we have a transversal, so that's a line that intersects, that cuts two or more, creating each time it intersects a line, a set of those four angles again. So four angles each time it intersects another line. That if the opposite alternating interior angle, so what does that mean? So if I take this one here, if I take the opposite side of the transversal but still inside across, so this one's below, this one's at the top, so it's created this Z shape. So they're alternating this side and that side. And if those two are equal in measurement, then those two lines must be parallel. So we can either use the fact that we know they're parallel to find alternate angles, or we can decide whether, and we can learn whether two lines are parallel by looking to see if their alternate angles are equal. And likewise, the alternate angles can go this way too. So this one here, the number 2, is alternate to number 4. And if those two are equal in measurement, so they have the same degrees, then that means that these two lines must be parallel. And then we looked at Theorem 5, which was regarding corresponding angles. So the same thing again, we've got a transversal line that cuts, intersects two or more, creating each time a set of four angles. And at this time, rather than looking for the Z's or looking at the X, if we look at these F shapes, so in other words, we look at what angle corresponds for each set of four. So if it's the bottom right one, the bottom right one is the corresponding one in the other sets of four. So 7 and 3 correspond. And Theorem 5 stated that if we know that these corresponding angles are exactly equal in measurement, so they have the same degrees, then that tells us that these lines must be parallel. And then likewise, if we're told in the beginning that these two lines are parallel, then we can work out different angles if we have the corresponding measurements. So I hope you got on well with your homework. I'll have sent you the solutions if you have submitted all of the correct the answers. If you haven't received them yet, just bear with me. It's taking some time to get some of these recordings done. Okay, so on the screen, I've got two lines here that are intersecting. Can you tell me which theorem am I going to be demonstrating then? Which theorem was it that we looked at, or what's it called? We don't necessarily need to learn that Theorem 1 is for a particular name, but we do need to know what it is that we're actually learning about this, the properties. It's the X shape. So if you can remember, the X shape was the vertically opposite angles, or VOA for short. And this is a really good demonstration. You see, it doesn't matter how small the gap or how close these two lines are. If I make them really far away like this, look, the opposite angles are the same. Let's move this a little bit closer. Look at the degree measurements now. The opposite angles are the same. And that's because if I rotate it this way, if I'm moving it 1 degree, it's moving 1 degree here too. So they're moving in the same proportion. So let's see it from a null angle there. And that helps us remember that there's 180 degrees on a straight line, so a straight angle. And as we start to increase, look, we've moved it, so it's 1 degree, 2 degrees, slowly increasing. So if these are increasing, then these are going down by the same rate because we're affecting the same circle as we're rotating these lines around. So you will always end up with opposites being equal in measurement. 107, 107. Okay, so can you figure out which of the theorems, perhaps just its name, is this demonstrating? So we have more than one line. We've got a line K and P. And how do I know that they are K and P are both a line? How do I know they're lines? Because they have lowercase letters. So small letters is the correct way to notate a line. Now look what's happening here. We've got a transversal that's cutting across the two of them. And that's creating a number of things. It's creating 4 angles up here and 4 angles down here. So you'll always get 4 angles when you have 2 lines or rays or segments intersecting each other, crossing each other. So if we look, we've got F's and we've got Z's, but which one is being demonstrated here? If you look at this line and I move down like this, we've got 2 angles that are equal in measurement. They're alternating, this side at the top, the other side at the bottom. This side at the bottom, the other side at the top. So this is alternate angles. And the fact that they're equal means that those 2 lines K and L, K and P, must be parallel. And that's Theorem 3. So it shows that if I continue to move those lines, and the reason why they have the same angle measurement is because you remember the properties of what it means to be parallel is there's always the same distance. So if you're moving one line, you'll have to move the other line exactly the same amount of degrees because they have to keep parallel, the same amount of distance. So it doesn't matter how much I move them, this and this stays the same, and this one and this one are equal. Not stays the same, but they're equal to each other. So whichever this one is, and so is this, 35 and 35. And then look again, we can demonstrate that the 2 of these together line a straight line, and they will always add up to 180. So if we're making it slightly steeper, then that means we're taking away from this degree measurement, but it's going to be more on this side. And that makes sense then that they're both being moved in the same amount. So they're going to still continue to be the same, these alternating angles. And then lastly, again, we've got this is demonstrating some of our corresponding angles. So in particular, it's looking at to the left of a transversal. So we have the same lines K and P again with this transversal down. And if we look at this lower set of 4 to the left and above the transversal, then its corresponding one on this set of 4 will also be to the left of the transversal and above the line. So looking at these two, as you can see, they're both 139 degrees. So if corresponding angles are equal in measurement, then that tells us that K and P most certainly are parallel, and we could then add our little arrow onto the 2 to show that. And likewise then, the other 2 that are being shown are also corresponding, these 2 that are 42. We've got to the right of the transversal and above, to the right and above. And it doesn't matter how we move or change those lines, you'll see that because they're parallel, they're going to be moving the same amount of degrees, so it's going to affect these measurements exactly in the same way. Okay, so I'm going to do an example question, one that's a little bit like what you had to do for homework last night. So if you look, it's page 289 in your textbook, exercise 18.1, and it's question 6. So I'm just going to have a look at this one here, which is 6a. And it says, in the following diagram, show two lines which intersect at the point B. So there's two lines and they're intersecting, so they're crossing. There's the point of intersection there at B. And look, you remember and recall that all points are labelled with a capital letter. Now our task is to find the size of the angles, so the measurement. You'll see that it has set out our preferred answer format, remembering that these two lines mean the measure of, and it's using the alternative notation for angles where we can follow the path that these three letters points take. So if I look at this first one here, so it's asking us to find the measure of the angle ABC. So if I follow that path, if I travel through A to B to C, then that's helping me know that it's wanting this particular measurement here. Okay, so to work it out, I have just reproduced it here for you. So we know that this is 120 degrees and we are looking to find this measurement here. So I'm going to use my knowledge of a straight line causes a straight angle of a measurement of 180 degrees. So if I'm looking for the angle ABC, which means it's travelled from A to B through C, creating this angle here, that we know that because it must be 180 minus that 120 that we don't want. And that's this bit here, we need to remove this part. And therefore, this implies, or we could use our 3 dots for therefore, that the measure of angle BC is 60 degrees. And we would then put it into the correct place in the exam or the test where it has asked you to write your final answer. But we're showing our full workings and making sure that in case we actually accidentally go wrong here, that we've picked up some attempt marks. And then once we have done that, I could label that onto my diagram. So don't be afraid in an exam to add on measurements because they might help you the next time. Because I can immediately see now that if I go back to looking at my points, so I've got D and E here. So I'll just add them on here, D and E. So if I look at the angle D to B to E, that's this one. Well, that is vertically opposite the angle that we have just calculated. So therefore, it must be equal in measurement. And I'm actually going to explain why, and I'm going to write VOA, vertically opposite angles. And down here, I'm going to write SA for straight angles. Now, the last thing is then A to B to E. So that's this measurement. And again, I can see that that's also vertically opposite the one that was given us in the question. So that's 120 degrees. And again, it's because it's vertically opposite angles. And there we have it. We've got our correct notation measurements with the symbols and our justification, the theorems that we have used. So lastly, we're going to look at doing a question from the next exercise. Again, exercise that I set you some work from last night, exercise 18.3. And this question that I'm going to do is question 13 from page 294. And this time we have two parallel lines, M and N. And we know that they're parallel because they do have these arrows, the same number of arrows. So it's the same measurement all the way across, and they're both lowercase letters, so we have two lines. And then we have a transversal that's cutting the two, and that's creating two sets of 4 angles. A top set here, the 4 around this intersection of the transversal and line M, and the 4 at the bottom around the intersection, the point of intersection there, between the transversal and the line N. So we're going to use our different property knowledges of the theorems 1, 3 and 5 and straight angles, and we could also use interior angles, lots of things, anything that we like as long as we justify what we've done. So we need to find A, B, C, D and E. Okay, so I've just drawn it out to help us here. So I'm going to start off with looking at my angle A. So I'm going to be trying to work out what the measurement of angle A is. So that's what these two lines are. What is the measurement of, or what's the distance if it's not an angle, of angle A? So that equals to, well, if I look at A, along with this 80 degrees, it lies on a straight line. It creates a straight angle, which we know is 180. So if I take away the 80 degrees that I don't want this part, I just want the rest of this straight angle, then I'm going to be left with our measurement of angle A. So 180 take away 80 means that our measurement for angle A is 100 degrees, and our reason is we used straight angles. Okay, so next then, now I might even just add that on if you wanted to in your diagram, you could, and then that helps you then if you're calculating other angles later on. Next it's turn for angle B. If I look at B, that's vertically opposite the 80 degrees that we were given in the question. So there's no workings that need to go with that, providing that I do state that I know it's because it's vertically opposite angles. And then on to C. If we look at C down here, now this is where some people get a bit stuck and they think, well, we've got no measurements here. But don't forget that these will correspond to the measurements up here. And because these two are parallel, then that means we can use Theorem 3 and 5, that they will be equal in measurements, the corresponding pairs. But you can also use your knowledge of two angles inside, interior angles within these parallel lines. They will add to make 80 degrees, so, to make 180, apologies. So that means this one must be 80 degrees, because together with A and C must make 180. Alternatively, you could have used the corresponding, it's to the left and above, to the left and above, so it corresponds with that 80 degrees. So 80 degrees, and we will put CA for corresponding angles. And then we have D, so I might just mark that on as well, 80 degrees there, because that helps me then to know that D, well, together with C, that creates the straight angle. So we know that straight angles, or straight lines, make a total of 180. So if we take off the C measurement of 80 degrees that we don't want, then that's going to give us 100 degrees for D. So I used straight angle. Okay, so that's 100. And then last of all, E, and I'm going to use vertically opposite angles again with C. There's the X. So that means no calculations required this time. I know it's 80 degrees because of vertically opposite angles. And there you have it. Your homework today then is to learn the keywords that you defined yesterday to do with this chapter. So if you recall, they were vertically opposite, transversal, alternate, corresponding, parallel, triangle, equilateral, isosceles, scalene, right-angled, and exterior angle. And that's giving you a little bit of an insight as to what we're moving on to on Thursday. Thursday's class, we're going to start looking at triangles. And then I'll also want you to do a page in your logbooks. And it's this page, page 41. Make sure that once you complete all the tasks that you do tick your self-assessment, so whether you feel that you needed a bit more help or whether you found that exercise fairly straightforward, and you have to do the whole page, so exercise 1 and exercise 2. And then I will see you in class for the next class on Thursday.